Yeah, very good morning to all of you. I'm sharing the QR code. Give the attendance, then we will start. Wait. Okay, so I think all of you have given the attendance. So we shall start. Okay. Yeah, I'm sharing a presentation with you. You just see here, we are moving to the second module. Okay, our first module is more or less done. Okay, no. Yesterday I was with some problem, right? Any problem was left for yesterday? Tell me. Yeah, one problem was left out now. Hello? That backlight problem is left out. Hello?
Yes, ma'am.
So that backlight problem is left out now.
Yes, ma'am.
Okay. So let's do that problem first, okay? That backlight problem. Wait, let me share my screen, my whiteboard. And the question is with you all. So I'm not showing the question to you. I'm just repeating the question once. A sheet of bakelite, 4.5 millimeter thick, is tested at 50 hertz between electrodes, 0.12 meter in diameter. The sharing bridge employs a standard air capacitor C2 of 106 PF, means picofarad capacitance. A non-reactive resistance R, R4 of 1000 by pi in parallel with a variable capacitor C4, a non-reactive variable resistance R3. Balance is obtained with C4 0.5 microfarad and R3 260. R3 is 260, right? Yeah, 260 ohm. So you have to calculate the capacitance, the power factor, and relative permittivity of the sheet. So yesterday I also have drawn the picture for you. So the picture comes very easy. Let me tell you once that also, because otherwise we won't be able to understand. Okay, wait.
मैम स्क्रीन दिख रहा है
बोलो.
मैम स्क्रीन नहीं दिख रहा है
नहीं दिख रहा है. Wait. I haven't shared. Screen नहीं दिख रहा है. But I have shared my whiteboard. I have shared
तो
my whiteboard. See, I'm writing something. Is it अभी दिख रहा है? Hello?
नो
हाँ?
नो मैम
नहीं दिख रहा है. Okay, wait. But I have shared the whiteboard. Why it's not visible? Now it is visible?
Yes, ma'am.
Okay.
नो मैम
कौन no बता रहा है? Who is
मैम
telling?
सुशीला
Sushila, others, Ayushi, is it visible?
Yes, ma'am, it is visible.
Sushila, you having some problem? Just check it out. Okay. You're having some problem, check it out. Okay. So in my question, my diagram will be like this. So if you have drawn the diagram, it's okay. I'm drawing it for my sake. This is the picture will be like this. And here you will be having a capacitor. Okay. And here you will be having another capacitor like this. So yesterday I have drawn, I think, and here we will be having a detector. This is C1, this is R1. Here I1 current will be flowing through this, and this is somehow R3. This is C2, this is C4, and here you will be having a resistance that is R4. Okay, this comes with variable resistance. Okay, variable resistance, variable capacitor. And here the terminals are A, this is B, this is C, this is D. This is the picture for the problem. Okay. Now this picture you have to make on your own, because in this kind of problem, pictures are not always given, are not always provided. Okay. Now here I2 current will be flowing, and through this again definitely I1 is flowing, and through this I2 is flowing. And through this capacitor IC current will be flowing, and through this resistance IR is flowing. Okay. And so everything we have done, the connections we have made, and here if you ask about the voltages, this is E1. Okay, this is E2. This portion is E3, and this portion is E4. Okay. Now, what was my question? Yes. So first of all, I told you that there are some equations of sharing bridge. Okay. So from those equations of sharing bridge, you have to write the equation for small r1. Okay. So sharing bridge here, small r1. What can be the equation of small r1? I think I told you C4 by C2 multiplied by R3 is my equation. So you know the values, right? You know, C4 is 0.5 microfarad, so it will be 10 to the power minus 6. Yeah, minus 6. C2 is something picofarad, so that will be 106 multiplied by 10 to the power minus 12. Okay, multiplied by R3. What is your R3? It's 260. Please do the calculation. Tell me the answer. R3 is 260 in your problem. Right? Yeah. It's 260. And C2 is somehow 106 picofarad. So do the calculation. Tell me the answer. Tell me the answer, please. Hello? So calculation, do the calculation, tell me the answer. Hello? Are you doing? Hello?
Yes, ma'am.
Okay, okay. If you have calculator, kindly do it. I don't have calculator with me right now. It will come something ohm, okay? What is the answer? Hello? This calculation is taking so much time. What is the answer? Hello? 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 Is anybody there? Hello?
Yes, ma'am.
So calculation, tell me the answer. This minimum calculation you are not able to do.
Ma'am,
Bolo.
ma'am, 1.22 into 10 to the power 6.
Okay, 10 to the power 6 ohm. Clear. Next is you have to find out the capacitance C1. So formula for it will be R4 by R3 multiplied by C2. Your R4, I think it's 1000. Okay, R3 is 1000 by pi. Okay, R4, and R3 is something 260. Okay, C2 is 106 picofarad. So 106 multiplied by 10 to the power minus 12 F. So tell me the answer. Just you do the calculation, please. So, tell me the answer doing the calculation. What is the answer of C1? I'm waiting for the answer. C1. What is C1?
Ma'am, 129 picofarad.
129 picofarad. Okay, fine. Actually, I don't have calculator, nah. That's why I'm depending on you.
Ma'am, 129.83.
Oh, 129.83. Then you can take it as
Yeah.
130. Okay.
Yes, ma'am,
Then you take it as
130.
130 picofarad. Okay. Then is power factor. You need to find out, right? What is the formula of power factor? Here the formula will be omega C1 small r1. Okay. You know what is your omega? Omega is 2 pi f. Okay. F is 50 hertz. It's given in the problem. Into C1. C1 is your, I think, 130. See in the problem it's given now. C1 is 130. No, sorry. C1 though we have derived. We have find out. So C1 is 130 multiplied by 10 to the power minus 12. Multiplied by small r1. Small r1 is 1.222 10 to the power 6. Like this. So you know what is F2 into pi. Okay, into 50 into 130 into 10 to the power minus 12 into 1.22 into 10 to the power 6. This you tell me the answer, please, of power factor. Power factor will be not having any unit. Okay, this is the power factor of sheet. Of sheet. Tell me the answer. If you are having subjective question exam now, then these questions would have come. Then in objective also this will come, but in part. Suppose you will be asked only power factor, you will be asked only capacitance, like that. Otherwise, it becomes a big problem. No. So some parts will come. So this equation.
0.997 into 10 to the power minus 3.
No.
Ma'am, 0.0049.
Yeah, 0.000049. Yeah, 049. 0.049 or 0049.
Ma'am, 0.049.
Yeah. So 049, we can take it as 5. Okay. We can take it as 5. So take it as 0.05. So my power factor is somehow 0.05. I'm going to the next page. I'm moving to the next page. So now you need to know the relative permittivity. Okay, so relative permittivity has a formula. Before that, capacitance 1. Where is the capacitance 1 situated? Here is the capacitance 1. C1. So it will be having a formula. What is that? Let us see. Now C1 is having a formula of epsilon R, epsilon 0, A upon D. Okay, if you remember, in case of relative permittivity, that is epsilon R, you can write the formula as C1D divided by epsilon 0A. Okay, what is your C1? What is your C1? It's somehow 130 into 10 to the power minus how much? Minus 12 now, because it was picofarad. Multiply by D. What is D in your question? a sheet of bakelite 4.5 millimeter thick. So that will be your D, diameter. Okay, 4.5 into 10 to the power minus 3 divided by epsilon 0. Epsilon 0, that is relative, it's a constant, it already having a value, that is what? 8 point, in physics we have learned now, 8.854 into 10 to the power minus 12. This is my formula for this epsilon. Okay, multiplied by area. It's a sheet. Okay, sheet is having area. You can take it, a sheet of bakelite, 2 electrodes. Yeah, so you can take and the electrodes 0.12 meter in diameter. So in that case, we can take it as pi by 4. It's a rectangular sheet. So 0.12 whole square. Okay, so area we will take like this. And this epsilon is my constant, which is called, actually epsilon is called, if you forgot, let me tell you, this permittivity of free space. Okay, permittivity, do the calculation please, of free space. This constant was in chapter, let me tell you, in physics or in Coulomb, electrostatic chapter you have. So this is the and the value of this is 8.84854. Yeah, sorry, wait, 854. 85 you can take, multiply by 10 to the power minus 12 per meter. Okay, so this is the value of permittivity of free space. So we have taken this. Please do the calculation and tell me the value of epsilon r, that is relative permittivity, which we need to find out from of the sheet. So this is relative permittivity of sheet. Okay, so this thing we have to find out. So tell me the answer.
I'm 6.2.
No, with a proper calculation. You have done something wrong. It will be within 6. The value will be less than 6. The value will be less than 6. Okay. Do the proper calculation. You have done something mistakes. Done the calculation. Anybody else who have done the calculation?
Ma'am, 5.8.
Yes, yes, very good. 5.8 something, right? 8 how much? 5.8? 5.8? 8 something, what? 5.8 how much? Hello? Pooja was telling me
10 to the
that.
power minus.
No, not that. 5.8, 6, 7 something or 7 something, what?
Ma'am, 5.0.
No, not 5.0. It will
Ma'am,
be
4.
8.4.
No, ma'am, 4.7.
Acha,
Ma'am, 5.47.
5.47. Okay, fine. This is the answer. Keep it this.
5.847.
Yes, 5.847. That I was thinking. 5.847. So you can
Yes.
somehow take it as 5.9. Okay, always try to, in measurement and instrumentation, whenever whatever problems you will do, try to make it a round figure or try to make it a whole number type. Okay, don't try to keep lots of number after decimal. Okay, so tum dekhna, whatever problems we have done till date, we have tried to keep it after decimal only one number. Okay, we have taken the significant figure, that concept. application of other concept in this subject. That is the thing. Okay, so this problem is done. Now, last problem I'll do in this chapter using Hayes bridge. Okay, so I think I have done problem with Maxwell. I have done problem with Anderson. I have done problem with sharing. And the last problem today we will be doing, that is using Hayes bridge. Okay, so that will be the last one. So let's take it down the problem. Take it, a bridge consists of, I think first let me see whether I have that in my documents. Let me see whether here I have the question or not. No. Leave it, I don't have. Okay. Let me explain to you. Okay, write down. A bridge consists of the following. A bridge consists of the following. Following means arm AB, a choke coil, having a resistance R1 and inductance L1. So one thing you do, you try to, whatever I'm writing now, you try to draw the diagram also on your own. Suppose in arm B, you are having a resistance and inductance. Okay, like that. So that is why I'm telling you like this. Arm AB is done. Now comes arm BC. Arm BC will be having a non-inductive resistance. Okay, let it be R2. Then comes arm CD. A mica condenser C4 in series with non-inductive resistance R4. Okay, and last arm DA, right, a non-inductive resistance R2. Okay, so these are the description of the four arms, how you will draw them. So when this bridge is fed from a source of 500 Hertz, that means we will take a frequency. So when this bridge is fed from a source of, suppose you take it, frequency is 500 Hertz. Balance is obtained under following conditions. Now when balance is obtained, at what values? You take it down at R2 is 2410 ohm, R3 is 750 ohm, C4 is 0.35 microfarad, and R4 is 64.5 ohm. Okay, so these are my values. Then you write a series the series resistance of capacitor is 0.4 ohm. Okay, calculate the resistance and inductance of the choke coil. Calculate the inductance and resistance of choke choke coil. And I'll show you the supply that will be between A and C. Let me, Acha, have you drawn the diagram? Okay, have you taken down the this problem? Then I'll go to the next page. Have you taken down this problem?
Yes, ma'am.
Okay, I'm going to the next page. Okay, now how the diagram will be look like? Check it out. I mean, if you have done, then you just match it with yours, whether you have done correctly or not. Okay, and you just match it whatever I have told you. Arm AB, arm BC, उसके साथ भी match कर लो, ठीक है? Because with the statement, the picture should match. This is capital R1, this is capital L1. Okay, this will be R3, this will be R2, and you can take this as C4 and this is as R4. Okay, and this is I1 is flowing, and through this I1 will be flowing obviously, and through this I2 is flowing, and definitely through this also I2 will be flowing. So here, if you draw a supply for it, and that will be something hertz, you know the frequency, just like this. Okay, and so you just match it with everything. See, arm AB, a choke coil having a resistance R1 C1. This is the arm AB, right? This is the arm AB. This one, arm AB having two things: resistance and inductance. Done. Arm AB is correct. Arm BC, non-inductive resistance. See, this arm BC is having R3, non-inductive resistance. Arm CD, which is CD? This one. This one is arm CD. Arm CD is having a mica condenser C4, this one, in series with resistance, inductive, non-inductive resistance R4. So these both are in series with each other. Okay. So your picture should match with your statement. And lastly, arm AD. Arm AD is having a non-inductive resistance. So this problem is going to be very easy because the circuit is not so complicated. So this is the picture of Hayes bridge. Okay, now again I'm telling you, see, in the problem, it is not mentioned which kind of bridge is this, right? See, if you check out the problem very minutely, here nowhere it's written what kind of problem is this. It's your task, it's your challenge that how you will understand that this kind, after, see, all the statements are given and you will draw the circuit. After drawing the circuit, you have to understand that which circuit is it matching? Anderson, T, sharing, Hayes, what? So it's your job. Okay. So this is a picture of Hayes bridge. So, and this is only possible after you sketch this kind of circuit from the statement given in the problem. Clear? So this is the Hayes bridge. Now, as per Hayes bridge, we have some particular formula. What is that? For inductance and resistance of the coil, if you check it out, my notes, inductance will be L1. L1 you can write R2, R3, C4. Okay, this is C4. C4 divided by 1 plus omega squared C4 squared R4 squared. So I think you are aware of all the values, right? So what are the values? 2410 multiplied by 750 multiplied by 0.35. That will be into 10 to the power minus 6 divided by omega will be 2 pi f. So 1 plus 2 pi f squared. So 2 pi f. F is 500, right? See, here I have given f is 500. In the problem, it's written here. So it will be 2 pi into 500 whole square. Okay. Or you can take it the full whole square. Don't make it single whole square because it's total whole square. C4 is how much? C4 is 0.35 into 10 to the power minus 6 multiplied by 64.9 whole square. Okay. Keep it total whole square. Tell me the answer. Something in Henry, it will come. Please do the calculation or मुझे बताओ what is the answer. Now let me write here the formula for R1. It will be omega square R2, R3, R4, C4 whole square divided by 1 plus omega square C4 whole square, R4 whole square. Okay, this kind of problem will come. Do the calculation, please. Acha, here also it's 2 pi into 500. It will be whole square. Multiply by R2 is 2410. R4 is 750. Sorry, R3. R3 is 750. Acha, R4 is something 64.5. And your C4 is something 0.35 into 10 to the power minus 6. This is whole square because C4 whole square now. And down it will be to the calculation of the top one first. And tell me the answer. Have you done the calculation of L1? Tell me the value of L1, please.
Ma'am, L1 is equals to 0.6 Henry.
0.63, correct. Do the second calculation.
Ma'am, 140 something.
बोलो कितना है 140 हाँ 140.5 something ohm it will come. Okay, so these are the values of the resistance and inductance of the choke coil. Now you see another value is given. The series resistance of the capacitor is 0.4 given now. This one thing, this one portion is given. That so how what to do with this? What to do with this? So we have to do what? See, in the arm CD, which is the arm CD, this one. This is the arm CD, this one. So in the arm CD, we are already having a resistance R4 that is 64.5 ohm, right? So we have to see that the resistance of the arm CD is the sum of the resistance of the series resistor and the series resistance of the capacitor. Okay, both. So we can take an R4 as, we can write R4 as 64.5 plus 0.4 that is given in the problem. So here in this case, you can take as R4 as 64.9 ohm. Okay, so this is exceptional case. In all problem, you won't get this. So if it's clearly written here that the series resistance of the capacitor means series resistance of the capacitor. Yes. So some resistance is if we connect here, then we can say that if somehow suppose here one resistance is connected like this R1 or something. So this R1 is having the resistance of 0.4 ohm. So if we add these two things, then we will get this answer. Okay. So this is the value which we are getting. Okay. Okay. Now you tell me, do you have any other query on this chapter? Because I think I have covered more or less this chapter and we have done so many problems also. Okay. So all problems are based on this. This is the basic problems. Methods are same. You need to apply the formula after identifying the bridges. This is the main task. Nothing more than that. First, you have to do the circuit diagram from the problem, and then you have to identify what kind of bridge is that. This is the whole task. So apart from that, there is no other process, there is no other method to solve these problems. Okay. And one problem which I have discussed with you in the 2 days back regarding polar form to complex number, that thing. So that's a special kind of problem. So you can also practice that because in some problem angle they may take. Okay, maximum time they don't they don't go for the angles, but in some problems it may happen they are accepting the angles and doing the calculation. So in that case, you have to convert the j form. Suppose x plus yj, that form of number. Okay, suppose you are having 0.5 minus j 0.6. Now this thing you have to convert it to something in angle term, right? This kind of angle term. So this is your main job in that case. So I have also give you some tips on how to do it, and how to identify in which quadrant it will fall. That's a very big issue to understand that which kind of complex number falls in which quadrant. Okay. Okay. Now, if you have any query, you can ask me. All the problems are done from this module 1. Then from next day, I mean tomorrow we have class. So tomorrow we can start with module 2. That is true voltmeter reading, all RMS reading and all. It's a bit boring, I know, but still we have to cover it. It's in your syllabus. Okay. So see, any query if you have, you can ask me. And the questions which I've given you, if in exam it will come from this. So don't worry for the questions. Okay, just practice all these problems and try to identify that in every problem they will not give you this is Hayes bridge, this is Anderson. You have to identify what kind of bridge is that. Okay. So thank you so much for attending the class. And anybody is left out giving the attendance, then wait, let me share the QR code once more. This is the QR code. So give the attendance if anybody has left out. Okay. So we will meet tomorrow at 10:40. Thank you so much.